All right, so everybody go ahead and take a look at the rewind problems. Hopefully you did them on the boards and you remembered the characteristics of polygons that we talked about yesterday. So going through numbers 1, 2, and 3, tell whether each figure is a polygon. Number 1, would this be a polygon? Yes, it would. It's a closed figure. All of the lines composing it are straight. It's two-dimensional, so it would be a polygon. It says if it's a polygon, name it by the number of sides. So to do that, we would just count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is actually a nonagon. For number 2 is a polygon, yes or no? Number 2 is not a polygon because it has a round top, so it is not composed all of straight lines. Is number 3 a polygon? Number 3 is not a polygon because it also has an open side right here. So this would not be a polygon because that side would be open. So that is not a polygon. All right, for numbers 5, 6, and 7, tell whether each polygon is regular or irregular. Number 5 is an irregular polygon. Number 6 is a regular polygon. And number 7 is an irregular polygon. How do you know if it is a regular polygon? You know if it's a regular polygon if all the sides and all of the angles are congruent. So taking a look at number 6, we have a regular octagon because all the sides and all the angles are congruent. So that's a regular octagon. Numbers 5 and 7 do not have congruent sides and congruent angles, therefore it's not a regular polygon, though they are polygons because they're closed figures, two-dimensional, etc., all of those characteristics we talked about yesterday. So moving on, today we're going to talk about a specific polygon, and we're going to spend a lot of time talking about parallelograms. And the reason we're going to spend a lot of time talking about parallelograms is because, as you guys might have noticed, we spent a lot of time talking about parallel lines in general. So parallelograms are quadrilaterals with two pairs of parallel sides. And a quadrilateral means what? It means that it is a figure that has 4 sides. That prefix quad means 4. So that prefix means that it has 4 sides, and it's called a parallelogram because the opposite sides are parallel, which means that in this figure here on the left, BC is parallel to AD, which we know because they're marked with those little arrows. And then we know that AB is parallel to CD, which we know because those are marked with 2 arrows, which means it's parallel to the other one that has 2 arrows. When we name this polygon, we use this symbol right here. So we essentially just draw a little polygon, and that polygon is a parallelogram. We draw a little parallelogram, and we call it ABCD. Could you call it BCDA, DCBA? Sure, you can call it anything as long as the letters follow in a specific order. So as long as you start with D, then you have to either go clockwise or counterclockwise. You can't skip around, but you can name it using whatever letters you want. You'll typically notice that I name things in alphabetical order if possible. So that's a parallelogram, and there are a lot of things that we can do and prove with parallelograms. So let's take a look at some of those things. All right, we have 4 theorems we're going to talk about today, and these theorems are all properties of parallelograms. It sounds like a lot. None of them are that complicated, so don't spend too much time worrying about the numbers right here. Just know the concept, because again, whenever you're using a 2-column proof, even if you don't know a theorem name or a theorem number, you can always just, in your reasons column, just explain what you're saying. So the first theorem that we're going to talk about is if a quadrilateral is a parallelogram, then its opposite sides are congruent, which just means in this figure right here, if this is a parallelogram, so if I tell you that it's a parallelogram, which we know that this one is because it's got those arrows, the opposite sides are parallel, and it's a quadrilateral, then that means that the opposite sides are going to be congruent. So for example, AB is congruent to CD. And BC is congruent to DA. So opposite sides of a parallelogram are always congruent. So taking a look down here at quadrilateral BRGL, if I tell you it's a parallelogram, then what can you tell me about LG and RG? Good, LG has to be 5, and RG has to be 12. Because if I know it's a parallelogram, then opposite sides have to be congruent. All right, the other 3 theorems are similar to one I just said regarding opposite sides or opposite angles. So we have 3 different theorems right here, and it looks like a ton of information when it's printed up here on the screen like this, but it's really pretty simple concepts. as long as you remember what your vocab is. So 6.2.2 says if a quadrilateral is a parallelogram, then opposite angles are congruent. We remember that opposite just means across from each other, so opposite angles are congruent. If I know that this quadrilateral right here, ABCD, is a parallelogram, which we do because it's got the arrows marked. Remember, you cannot assume anything. So if I did not have those arrows, could you assume that it's a parallelogram? No. Even if it looks like a parallelogram, you cannot assume it unless they give you those arrows. But they do give you those arrows. So ABCD is definitely a parallelogram, has 4 sides, and the opposite sides are parallel. So that means that opposite angles are congruent. So B is equal to D, and A is equal to C. Since it's a parallelogram, we also know opposite sides are congruent because we just talked about that, right? So BC is congruent to AD and AB is congruent to CD. So there's already 2 things that you know about parallelograms. In 6.2.3, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So there's some vocab in there that we're familiar with and some vocab in there that's new. And the word that's new is consecutive. And I'm going to ask you to think for a second about what you think that might mean, consecutive. So when we think of things like consecutive numbers, we would say that 2, 3, 4 are consecutive numbers. Or if we say that something happened over the course of 4 consecutive months, it would be like January, February, March, April. So consecutive means then in order. So when we're talking about consecutive angles, we're talking about angles that are in order. So for example, angle A and angle B are consecutive angles because they're right next to each other. So we know that those consecutive angles are supplementary. And supplementary is a word we're familiar with. Supplementary means that they add up to what? Good, they add up to 180. So those A and B angles add up to 180. And D and C also add up to 180. I know that if A and B add up to 180, BC also adds up to 180, and AD also adds up to 180, because every pair of consecutive angles is supplementary. And the last one, again, I know this is a lot of information, but it's pretty intuitive once you start to think about it. So the last one says 6.2.4, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So again, we've got some new vocab, some old vocab in here. We know that bisect means what? I'm sure that you are all shouting out that bisect means to cut in half, right? So bisect means cut in half. What is a diagonal? That's a new word for us. What is diagonal? The diagonal is the line that crosses from opposite vertex to opposite vertex. So for example, A and C, segment AC is a diagonal because it goes diagonally across the figure. BD is also a diagonal because it goes across the figure. So BD goes diagonally across parallelogram ABCD. All right, now this theorem says that if it's a parallelogram, again, we know that it is because of these arrows here, then the diagonals bisect each other. So that means bisect again means cut in half. So if these are the diagonals, AC and BD, then this Z is a midpoint. So that means BZ is congruent to ZD. It also means that AZ is congruent to ZC, because where those diagonals intersect, where they cross each other, they bisect, so they cut right in half. So that was a lot of information. How can we use that? So take a look at these try it out problems. The first one says find AD. AD is an angle or a segment? Good, AD is a segment. It only has 2 letters, so it has to be a segment. And so we're talking about this segment down here. And we know that AD is 7x, so 7x is AD. How can I find that? So what do I need to do? Is there anything else I know? Okay, just looking at this, before I do anything, I'm going to go ahead and put these on here for you. All right, and hopefully all of you were thinking, I can't do anything because it's not a parallelogram, or I don't know that it's a parallelogram, all right? Because I don't know for sure that it's a parallelogram. But let's assume that it is because I drew those arrows on there for you. So now, what can you tell me about AD? AD has to be congruent to BC. Perfect, because opposite sides have to be congruent to each other. That's 6.2.1. So opposite sides are congruent to each other. So I can set up an equation. What equation could I set up here? 7x equals 5x plus 19. And then how would I solve that? Go ahead and move the 5x to the other side. And you end up with 2x equals 19. And then to finish that, x equals 9.5, right? 9.5. Are you done? No, because you're asked to find AD. So now I have to plug that back in, and I do 9.5 times 7. 7 times 5 is, 7 times 9 is, plus 3 is 66. I move my decimal over once, so AD is 66.5. AD equals 66.5. All right, and the second question says find MB. So this M right here means measure of. Find the measure of, and this little symbol means angle, angle B. So I'm looking for the measure of angle B. I know that angle B right here is 6y plus 5. What's the other angle that I know in this picture? I'm going to erase my symbols from before just so you guys can get a clearer picture. I also know that this angle down here is 10y minus 1. So that angle A is 10y minus 1. Can I say that those are equal to each other? Hopefully you guys are saying, no, I cannot say that they're equal to each other because they're not opposite. However, they are what? They're consecutive angles, which means that they add up to 180. Perfect. So I can set up this equation. 6y plus 5 plus 10y minus 1 equals 180, because consecutive angles in a parallelogram are going to add up to 180. They're supplementary, so they add up to 180. So I combine like terms, and I get 16y plus 4 equals 180. I subtract 4, and I get 176 equals 16y. And then I divide by 16, and double check me on your calculators, but I believe it is y equals 11. And then the last thing you need to do is plug that back in to find the measure of angle B. So I'm going to do 6 times 11 plus 5, which is 66 plus 5, which equals 71. All right, since it's an angle, make sure you put your degrees symbol. So the measure of angle B is 71 degrees. Okay, so I want you guys to go ahead and do these practice problems at your board. So again, you're finding the indicated measures for 3, 4, 5, 6, 7, and 8. Keep in mind those 4 theorems we talked about. Some of these are very simplistic, some of these are a little bit more complicated, but make sure that you're really careful with what angles go with what and what bisect means. All right, so go ahead and do those 6 practice problems at your board. Okay, if you have questions on any of those, please feel free to shoot me an email, and I can go over any of those with you guys in class on Monday if you have any that you could not figure out. Again, some of them were a lot simpler, some of them were a little bit more challenging. Assuming that all of those are parallelograms, you should have been able to fill in a lot of information about those. Okay, so now we're going to take a look at a couple more challenging problems. So we're going to do one on a coordinate plane, and then we're going to look at one 2-column proof. So the first thing that we're doing here is we're solving a problem on a coordinate plane. And before you do anything, when I read this problem, I have a ton of information in this problem. I have 3 vertices of this parallelogram ABCD. I am looking for the coordinate of whatever vertex I don't have. So keep in mind the 4 things that we talked about with parallelograms, and let's see if we can figure out one that would help us here. All right, so 3 vertices of ABCD. I want to plot those first thing. So I'm going to plot A at 1, negative 2, so over 1, down 2. I'm going to plot B at negative 2, up 3. And I'm going to plot D at 5, 1. So over 5, down, to negative 1. So that would be D. All right, so I've got AD right here and BA right here. And I need to put C somewhere so that it makes a parallelogram ABCD. All right, so I need it to make a parallelogram. So if you had to guess on what quadrant C would be in, what would you guess? I would guess probably somewhere in quadrant 1, right? Like it's going to be somewhere in this area because I need that to complete this parallelogram. I couldn't put it like down over here or that wouldn't make a parallelogram. So I know that it's got to be somewhere there, but I need to figure out exactly where it needs to be. So how could I do that? How can I figure out exactly where it needs to be? All right, so we know that in a parallelogram, opposite sides have to be parallel to each other, which means that the slopes of parallel lines, we know the slopes of parallel lines are the same. So it means the slope of whatever line is opposite has to be the same as the slope of the line that we have. So for example, we have AD right here. What is the slope of AD? You go up 1 and then over 4. All right, what about the slope of AB? The slope of AB is down 1, 2, 3, 4, 5, down 5, over 3. All right, so the slope of that is negative 5 over 3. So that means wherever I put point C, the slope from C to D has to be the same as this, and the slope from B to C has to be the same as this. So that means to plot that point, let me just try to go up 1 over 4 from B. I go up 1, 1, 2, 3, 4. Maybe this is C. Let's check. So if the slope is 1 over 4 there, then that's right. What's the slope from C to D? Down 1, 2, 3, 4, 5 over 1, 2, 3. So my slope there is negative 5 over 3. So those lines are parallel to each other, which means that's the correct placement for those. How could we double check this? What's something we could do to double check this? Not only are the opposite sides parallel, but they also have to be congruent. So if you want to double check it, you could use the distance formula to find the distance of the segments BC, AD, and find out if they were congruent. Okay? Since the slopes are the same and it's a quadrilateral, the opposite sides are parallel, we are all good. That's all we need to know. And we were right that C has to go somewhere in that first quadrant. All right, the last thing I want to go over is a two-column proof. How would I use this information in a two-column proof? And I know you guys are all super excited because you haven't been doing a lot of two-column proofs over Christmas break, so you're glad to be back at it. All right, so in this two-column proof, remember the first thing I always said with the two-column proof is write down your givens. On your slides, you guys actually already have the entire proof, so you don't need to copy this all down. I don't want you guys to have to write this all down, but I do want you to watch as we go through this together. Okay, so we've copied down our givens, and we already know, based on this picture, that this is a parallelogram, so there's a lot of information that we have. But let's take a look at what we're trying to prove before we start to do it, because if we don't know where we're going, it's hard to get there. So we're trying to prove that angle BAD is congruent to DCB. So BAD is this angle right here, and we're trying to prove that it is congruent to angle DCB, which is right here. All right, and we also are trying to prove that ABC, which is this angle right here, is congruent to angle CDA, which is right here. All right, so since I know that this is a parallelogram, then I can prove this already, right? Because what are angle A and C? So BAD, which I'm also just going to call angle A, it's right here. BAD is congruent to DCB, based on what theorem? That opposite angles in a parallelogram are congruent. And we can actually use that same thing to prove ABC is congruent to CDA. Okay, so I don't even need to rewrite that. I'm just going to use those little quotes to say the same exact thing. Opposite angles in a parallelogram are congruent. So when you're doing two-column proofs, a lot of times I think you guys come into them thinking like, I'm going to hate this, this is going to be super hard. If you read carefully and write down all the information that you have, a lot of times the two-column proof kind of writes itself, right? We don't even need to do anything here to prove this because we have these opposite angles that are already congruent. All right, so I know that those are already congruent. What if I didn't know that theorem? Is there another way I could do this if I did not know that theorem? Sure, there's always another way you could do something, right? So if you forgot the theorem that opposite angles in a parallelogram are congruent, there is definitely another way that you can do this. And you guys have this one written down on your slides. So take a look at your slide. And what you'll notice here is that in this parallelogram, this splits it into two triangles. This way, and then I'm going to use a different color. It also splits it into two triangles this way. All right, so we can use information that we have used before to prove that parts of triangles are congruent, and that's another way that we can prove that these angles are equal to each other. So take a look at the proof on your paper, and I'm just going to go through it really quickly. But again, we can talk about this on Monday when I come back if you'd like to go over it. So we still write our given first. Then we might note that AB is congruent to CD, and that DA is congruent to BC because they're opposite sides of a parallelogram, so they must be congruent. All right, I can also say that BD is equal to BD because of my favorite, the reflexive property. So now that I know that, I've got three sides of these triangles right here. So I've got triangle BAD is congruent to DCB based on SSS. And think back to pre-Christmas break, SSS means side, side, side. So we've proved all three sides of the triangles are congruent. All right, and once we know that, then we can prove our first thing, BAD is congruent to DCB because of CPCTC. Again, CPCTC means that corresponding parts of congruent triangles are congruent. So if I know that these two triangles are congruent, then all their parts are congruent. Therefore, those two angles are congruent. All right? And we can do the same thing with the other triangles to prove these other angles right here. So that's what you see in steps 6, 7, and 8. All right? This proof looks a whole lot more complicated. All right, so what I'm trying to show you here is that there's lots of different ways to get to the answer in a two-column proof. Here are two very different ways. This first one was really simple. This second one made it a little more complicated, but not any less correct, okay? Both of those are right. They just went about it in a different way. The most important thing to remember is you've always got to write your givens, and you've always got to look at what you're trying to prove. See if you can figure out a simpler way to get there by looking at what you're trying to prove before you just start saying stuff and writing stuff down, okay? And then my last tip is always mark stuff as you do it. So you saw, as I said they were congruent, I put the little hash marks on the picture. Okay, so the last thing I want you guys to do then is to go to your boards and try this two-column proof. Okay, hopefully you were able to get to the proof in this two-column proof. If you were not able to, let's go through it really quickly right now. We know that GHJN and JKLM are parallelograms. I also know that HM are collinear and NK are also collinear, which just means that they are on the same line. So again, the first thing I want to write is all my givens, GHJN and JKLM are parallelograms. All right, HM and N and K are collinear. I'm consolidating it just a little bit to save time. All right, so 1 and 2 are givens. I'm trying to prove that angle G right here and angle L right here, I want to prove that they're congruent. Okay, so the first thing I want to do, since I know I want to prove those, is I can say that angle G is congruent to angle J, because they are opposite angles, and opposite angles in a parallelogram must be congruent. So opposite angles are congruent. That also goes for angle J and angle L. All right, so that also goes for angle J and angle L. I just caught myself making a mistake though. Does anyone know what mistake I just made? Okay, I cannot call this angle J. I can't call it J because J could work for this angle and it also could work for this angle right here. So I need to be more specific. So instead of calling this one J, I'm going to say that angle G is congruent to angle HJN. And then I'm going to say that angle KJM is congruent to angle L. And both of the reasons are the same. Opposite angles are congruent. Okay? Now, once I said that, now I can say that angle HJN is congruent to angle KJM based on the fact that they are what? These two angles right here are what type of angles? Good, those are vertical angles. Okay? And now we're going to take a little bit of a leap. And we're going to say if angle G is congruent to HJN and HJN is congruent to KJM, then I can also say angle G is congruent to angle KJM. What did I use to get there? What did I use to get there? Angle G was congruent to HJN. Now it's congruent to KJM. What did I do? I substituted, right? I took out the HJN and I plugged in the KJM because they were congruent. So I used the substitution property there. All right? And then last but not least, now I'm ready to say angle G is congruent to angle L, because if angle G is congruent to KJM and KJM is congruent to L, then I can cut out the middleman using the transitive property and say that they're congruent to each other. Okay, that was a lot. There was a lot going on in this lesson, so if you have any questions, please, please, please feel free to shoot me an email over the weekend, or we will go ahead and get together on all of this on Monday if you have any questions. But for now, I'd like you to try the exit ticket. Go ahead and do the exit ticket on the actual slides and turn those into your subs so that they can give those to me so that I can grade those, all right? Have a great weekend.